Okay, so I was asked to speak in English. Is everyone okay with that?
Yeah, sure.
Okay. Awesome. All right. So I'm Benji. This is all the boring stuff I do. I work on front-end architecture in Microsoft for the Excel team. That's like the literal Microsoft Excel. I work on Node.js. That's the capacity I'm here today as a Node team member rather than talking about my work in Microsoft. I worked in Testim.io, in Peer 5, and in TipRanks beforehand, yada yada, Stack Overflow, yada yada GitHub. All right, my opinions do not represent the opinions of Microsoft. They don't represent any of the organizations I'm involved with. I am a WWG member and a TC39 member. What I'm going to say about APIs is not representative of these organizations. It's just my personal opinion. Right. Who here does mostly JavaScript? Awesome. It's a web developers meetup. Sometimes people do mostly HTML, don't do very much JavaScript. So I wanted to check. The title in the talk was software architect. I am not an architect. Software developer or code monkey is fine. Architect is a very scary term for people who talk about code but don't write code. I write code, and obviously I'm here, so I talk about code, but I do more writing than talking. If anything I say is unclear, or I'm speaking too fast, or I'm not making any sense, or I have a bug, please be Israeli and shout, stop, you're wrong, all that. I have too many slides. If I'm boring or I'm slow, tell me. If I'm going too fast, let me know. We have too much stuff to cover intentionally, and we'll see how we get. I'll start the timer. Right. So first thing I want to mention is we give stuff we don't understand fancy names. So let's know that. What are streams? I heard that's scary. What are streams in Node? That's a particular types of streams. They are complicated. And are they fun? Right? So streams in Node, I think I have that slide maybe later. I always ask people in the in the group, who here is a Node streams expert? Who here knows how to use Node streams? No one is a Node streams expert. Not me. Maybe Robert. There is one guy in Node. He's kind of a streams expert. That's it. I've been maintaining it for maybe 5 years at this point. I am not a Node streams expert. It's a very complicated API. And you don't have to use the bad parts. And we'll see. So let's do some definitions and some warm-up before we show the beauty that is Node streams. Some simple stuff. A producer is something that gives me values. A consumer is something that reads values. So far, so good. A setter is something that takes something and returns nothing, like a setter on an object, set whatever, or it takes a value and it does something magic with it, and it steals it and it gives me nothing back in return. A getter, on the other end, takes nothing and gives me value. It's like a magic thing that creates something out of nothing. So what is a stream? Maybe we can get a definition. No one knows. Like I said, I did this poll in big international conferences, in small meetups, in Node developer groups, in Java developer groups. Everywhere, no one knows streams in Node for sure, or streams in general are very hard to define. So let's try to define it. It's something very abstract that lets us process data, also very abstract, in parts, also very abstract. So let's try this definition and see if it works for us. So I'm going to scare you, or not, or I'm going to make you happy. Here is some C. Is this a stream? No. Yes? Why? Right, it lets us process stuff in Start. That is correct. That is, for all intents and purposes, a way to implement streams. I have the read method that lets us read stuff. I'd ask the same question for C++, but they literally called it iostream. So pretty much a giveaway. Here's a harder one. What about this? Is this a stream? Well, kinda, yeah. So it takes all the clicks, and it lets us process them one at a time. So it does meet our definition. It lets us process the clicks one by one. It's temporal, right? You get a click when the click happens, but essentially, it's the same thing. What about this? So I'll go over the code really quick. Why is this? Like the whole slide is, never mind. So it's like there is a function that returns a function that returns the number 1. And we call the outer function that returns the inner function that returns 1. Then we call the inner function and it gets 1. And if we call the inner function again, it will return 1. Is this a stream? Well, kinda, right? We have data here, the getf, and we call it. It gets us something, and we can call that something to get data in parts. Like maybe this is like an HTTP request, and this function, which would probably be async because we're in JavaScript, would return the next few bytes from the request body. So when we think about streams, we think about these like very complicated structures. But essentially, this is a stream too. So what about this? So we have a function here. And we do set interval, and we call the function with the next integer. And then we have a closure here over the integer, and we call console log here. Is this a stream? Is there data that we are processing in parts? Yes, good. Right, so basically anything that lets us, based on our definition, process data in parts. We can name the function call. We get an observable, that's like an RxJS observable, that maybe makes it clearer that it's a stream because it lets us process stuff in parts, but it's also a stream.
Sorry.
Yeah, question?
What about the parts? You say all the time about the parts, but in all the cases, any function returns something in a part. Like
yeah, so here, like the parts are just numbers.
no, I mean, you say like parts, but like they return the whole, the common.
Yeah, so here every function call, like this one, will like get the next number. So the next number is just the next number to be simple. But imagine you are Node.js and you're like reading files and then writing that to like an HTTP request. So that would not be a number. It would just be like the next few bytes from the file. So do we want to hear some philosophy about streams? Yes or no? Yeah, OK. So I have some yes. I can skip this, but let's try it. So streams, you remember that what a getter is? That like the magic thing that produces a value, or a setter, the thing that like takes a value and steals it. So streams are all getters to getters or setters to setters. Mind blowing. Right, let's check. So this is a JavaScript iteration protocol. If you're not super familiar with it, that's fine. Stuff in JavaScript has an API called symbol.iterator. It's a symbol that objects have, like arrays or node lists. And you can call next, and that gets the next item. Right. I don't know if it doesn't do the thing. Right. We have like a get iterator here. That's the getter. And then we call it. That's the same thing, right? My array symbol iterator is like get iterator. And then iterator2 is the call. So essentially, this is a getter, and this is a getter. It produces values magically. We call .next, and out of nowhere, it conjures like values. I will skip the setter example just because it takes more time, but basically it's the same thing. Every time I have an event listener, it's a getter to getter or a setter to a setter. Here's the C file API from example. I forgot to change the name from like another conference, but it does fopen, that's a get, and then it does read. Read is like the second getter. It gets us values out of nothing. So every stream we have, and I'll give you like a spoiler. It's called typically push or pull. in terms of the stream. Either the consumer can ask for data, I can pull stuff from the stream, like symbol.iterator, or it can push stuff to me, like add event listener. Push and pull are terms that are used like very confusingly. When you say push, people think of like push notifications, but when you hear push, just think of a function call. In push, you pass someone a function and they call your function, they control it, like a setter. Like they call your setter and like give you the value. And in pull, you ask for the data, like a getter. You ask, you next, and so on. So like, I forgot I have a slide for this, I added it. If I do add event listener, I pass it a setter, and remember, the signature of a setter is something that takes a value and steals it. It doesn't produce anything. And the producer pushes the data. That's just called a push stream, right? A stream where the producer pushes the data is a setter to a setter, is just this like add event listener. Like the thing that makes it a push stream is the fact that I pass it a setter, I pass it like a function that takes an argument, and it calls me whenever it wants. Now, the getter case, like iterators, the consumer asks for the data. So this is a 408. Those unfamiliar, it's the JavaScript async iteration protocol. It's basically the same thing as symbol.iterator, but next returns a promise. And basically, whenever this 408 iterates, it will wait for the next thing from create read stream, which is a real Node API, by the way, to happen. So whenever it gets here to the auth, it will like pull the next item from the file stream, and it will process it. Basically, in the getter case, like here, where they call next, the consumer asks for the data. So if I do create read stream and I never read anything, Node is at liberty to never open the file, never read a byte. All the control is with the consumer. The consumer asks for the data when it needs to. Now, this can be explicit, right? I showed the example with 408 because that's the API you would use, but I can get an async iterator and call next manually. And in the previous example, because of the way 408 works, I can decide not to pull more data in my read stream until process finishes. So I can be very conservative about memory. Yeah. So a pull stream is a stream where the consumer, me, typically, asks for the data. Right? It's like a getter to a getter. I get something that I can magically call next on, and it produces values. So in a pull stream, like the getter to the getter, like iterators, the control is with the consumer, whoever, like my API consumer, whoever is using my code. With a push stream, like add event listener, the control is with the producer, the one creating like owning the resource for the stream. Like add event listener. Like if I do add event listener scroll, I will get bombarded with like 1 million scroll events, and it's up to me to like filter them. And if I want them less frequently, there is actually an API for that, but that's not the point. Like I don't control it. And if I have an RxJS observable for like for data and it comes too fast, that's my problem, right? There is actually a third way. If I have time in the end, I will mention it. I probably won't. So examples, like a pull stream is like an async iterator. It's like the C file API. And a push stream is like an event listener or an RxJS observable. So which of these is better in your opinion? Who here thinks like a pull stream is better?
They're different.
Okay, what do you mean?
This is getter, this is setter. The purpose of them is different.
It's like asking what's better, a server or client. They both
Yeah.
have purposes.
Yeah. So I can technically like take an async iterator and make an async iterator for mouse clicks, and it would work, right? And I could further weight it, which would pump it, and it would work. Why don't I? Why do I do add event listener? Conversely, I could take node streams and implement them on top of RxJS and just have subscribe. Right? So the answer is, when no one understands stuff like as well as we'd like, us computer scientists will always say it depends, right? We are very good at not understanding stuff well enough and like justifying our misunderstanding by saying it depends. It's like a technical argument. So the answer is it depends. I honestly don't know. Like I wish I had a like better correct answer. But imagine this case. So we have a Node API. It creates a stream from like the request. Create read stream takes a file and returns a Node stream, which I remember I haven't like really shown yet. And then it logs to analytics, and then it compresses it, and then it sends it to the request, and the APIs are fake, just to show. So what if, like, this is fast, this is sometimes slow, and this is fast and this is fast. So what if it's slow for some data? So here is like maybe smart, maybe dumb idea. Let's buffer the data. Let's just, when we do this, let's buffer like a megabyte from request.someParameter. And then if this is slow, that's fine. And this can buffer, everything can buffer except the slow part. And then the fact that it's slow 10% of the time doesn't bother us because it's fast the rest of the time and we absorb it. So does anyone know what buffering the data is called in streams? Yes, no one knows this. We have people working on Node for 15 years in the core team with like 2,000 PRs. So that's actually what watermarks do. So watermarks, כמו קו המים בכנרת, קו אדום עליון, קו אדום תחתון, like like actual watermarks. What they mean is like if you're below this number, you need to buffer more, and if you're above this number, you need to never buffer. Like you open the floodgates. So typically in Node, the watermark is basically you ask for more data until it reaches the number. You have like a file stream. Its watermark is like a megabyte, and it will read stuff from the file up to a megabyte, so you don't wait for file I/O each time. And it will actually read it in chunks. So this sounds like a good idea, but it's also risky, because when you have buffers, especially if you can get unbounded buffers, it's like a memory leak waiting to happen. Another thing is, in Node, we have one watermark. We used to have two. No one was using, there's like a high watermark, which we have right now. There was a low watermark. It got removed like 10 years ago. The rationale was, if people ask for it, we'll bring it back. No one asked for it. Good for us. Let's go to support. The streams code is terrible anyway. Right. This is a different stream. This is the MP4 stream of Chrome. When you watch a video in Chrome, and it's not HTTP live streaming, it's like an MP4. This is the buffering algorithm Chrome uses. I'm not going to go over it, but it's a pretty complicated algorithm with low and high watermarks of how much data Chrome will buffer. But it basically shows the same thing. Now, what if this is low, like broadly compressed? Remember, streams is something that does process data in parts, right? We need a way to say stop sending data. Like imagine we do this, we read a file, then we log to analytics, we get here, and this part is slow. If this part is related to web requests or like another server, we really don't want to basically, we need a way to tell this part and this part not to send us any more data. Yes?
Let's take the example of the MP4 before.
Mm-hmm.
You reach the highest level.
Mm-hmm.
Is this point the loading cause when I see the movie?
No, so what you mentioned is a buffer stall. A buffer stall is when the buffer is entirely empty. That's when you see a stall, like the loading. And this is when the buffer is entirely empty. Right, so when it's entirely empty. So, but like it's also another good example for the next one. So let's say I'm watching a video. I don't want to buffer too much data on the computer ahead of time. It's wasteful to the server, it's wasteful to the client. I need a way to say, hey, I have enough. Stop sending it so fast. There is actually congestion control on the server. Like you can control how fast the server sends the data.
If you load a lot of data, so there's the chugging there?
Mm-hmm. So chunking. So we need a way to tell like upstream to stop sending data. So in pull streams, this is very easy, remember. So let's say we have this code, let's say we have this code. We can just, if this is a pull stream that does like next, 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 like an async iterator, we can just stop calling next. And things will work, right? We have like a fetch HTTP request. We do like for wait over the request body. And we need to hit some API. We just stop reading the request body until like the API returns. It's very easy. Because remember, in pull strings, the consumer is in control. I can just say, stop calling next, and all is good. In push strings, we're kind of stuck, right? In push streams, like we get like add event listener, we don't really have an easy way to say like enough. Stop sending me data. So another scary term, syncing speed between streams, like the idea of being too fast or being too slow, is called pressure or back pressure. Back pressure is like one of those terms like monads, where it's scary for no reason, but when you try to explain it, it becomes scarier. So once, so pressure is basically let me become scary. I want to embed data, but I can't, right? And back pressure is basically the one we were talking about, where I want to, Back pressure is basically I'm getting data too fast, please slow down. Right, another cool term is what sort of data do we want to store in the stream? Like in C, we had bytes. You basically pass it an array and it fills it in for you. In RxJS, you have objects. What do you think we have in, that's a question when you design a stream API. So we think we know the basics of like terminology in streaming now. So here is something from the Zen of Python. There should be one, and ideally only one way to do something. Now let's explore the creativity and like, how do you say in corporate speak, like the challenge that is node streams. So do you know the joke where someone asks you, hey, do you want like a cake or like a cupcake? And you say yes to mean both things. Imagine abstracting your core abstraction, like designing your core abstraction, the thing that everything uses, like HTTP request, around that principle. So does anyone know if node streams are push or pull?
Yes.
Yes, exactly. Node streams have 3 reading modes. Now, does anyone know how to change reading modes in node streams? Exactly. That's one of the more confusing parts. If you listen to the data event, it will read the stream in push mode. If you listen to the readable event, it will read the stream in pull mode. And Node, just to be confusing, uses different terminology. We'll call it flowing mode versus non-flowing mode to mean push versus like pull. And there is a shrug mode that sets readable flowing to null. That's like we haven't reading it. And basically, the decision is based on adding the event listener. I'm not sure why the decision was made. My guess is back in the 0.8 days, we had fake streams that didn't have this like behavior, and they added pull mode in retrospect. There was a pause resume API for the push mode. It didn't work well, and it was added later, and it was backwards compatibility with a version of Node that no one has been using for 10 years. So software development for you, not fun. Does anyone know if Node streams use bytes or objects? Yeah, bytes. That's a good guess. Yeah. Another guess? Yes. OK, yes. Yes is a good guess. So the design is about bytes. That's the important part. Like HTTP request, everything is bytes. We don't want to serialize stuff from bytes or 2 bytes if we don't have to. But in passing, when Dominic was working on streams too, that's the name of the streams API we have, Jake, like Reynos, suggested, hey, wouldn't it be cool if every stream had an object mode property? And if it's on, it's an object stream. And if it's off, which is default sometimes, it's like it's a byte stream. So now streams have 3 read modes and an object mode, which is fun. It actually gets worse. There is like a legacy streams API that I briefly mentioned. But I don't want to get into it. It behaves differently with regards to some of the methods. Right. So just to be clear, the people who wrote streams, like the original implementation, they're smarter than me. They're good engineers. It's just like a matter of exploration, and designing APIs for large amounts of people is very hard. So they were innovating. They didn't have people to look at their design 10 years in the future and tell them, haha, don't do that. And I feel this very hard with APIs I worked on a board signal. I found a really, how do I say it, catastrophic failure in how we do cancellation, to the point where a safety guarantee we provide is actually false. And I found it 2 weeks ago. So these sort of things happen, and when we worked on promises, we ran into it. It's complicated. So why do people hate streams or things that are complicated? So let's say we have a stream of numbers, and we want a stream of numbers times 2. What is the node way, or the way people are familiar with? So let me try an example first. If we had an array, and we had an array of numbers, and we wanted to multiply each number by 2, what would we do? Map. OK, that's transform stream. That's the horrible one, but map is correct for array. So in Node, again, like you said, we would have a stream. That's how we create a stream, right? We do new class extends readable, or we do have simplified construction, where we do it in slightly less code. Instead of doing class extends, we do new readable, and we pass those in, and we do this.data 1 to 3, and we do push, and we want to transform it. And like the person here said, we override transform, and then we call the callback, which chunks times 2. This sucks. It's not the code you wanted to write, right? If we had an array, we would just map it. When we had getters to getters and very short code, things were nice. We were happy. Can't we have nice things? So the first thing we do is we can do simplified construction, like I mentioned. Again, this is our friend object mode that was added by a happy accident. Transform string, similarly. And our code is still not fun. Let's try again. So for creating a fixed stream, or a stream from an async iterator, or anything that Node understands, like a web stream, we can just do readable.from, which is much nicer. Anything that this will gobble up anything. And this is actually OK. If we had an array and we wanted to create an array from a non-array, we would do array.from. What about transforming it? So we have this API called compose that you can pass it like stream or stream-like, like an array. Anything that's readable.from that can eat up, and pass it in async generator. And then you can iterate the generator for wait const item of input and yield an item. And honestly, this isn't awful. This code is not the code I would typically write for happy stuff. But in terms of sadness, it's a lot less sad than the code before. Right. So that isn't awful, but can we do better? So right, like I said, if we had an array, we would just map it. It's also fundamental and profound. Yeah, I don't want to go over functors. I'm sorry, I'm out of time. Yeah, not end of functors, not monads. Yeah, right. So 2 years ago, a friend and a fellow Node.js maintainers came to a conference called NodeTLV. And that's Ronak. That's the one dude I said that actually understands the stream state machinery correctly. A lot of us think we understand it, but then we see a pull request, and we think it looks OK. And then he sees it, and he said, no. There's this edge case if you convert Never mind. So he was giving a talk about Compose. That was a new API. I approached him and asked, hey, so that's not the API people want. Can't we give them the API they want? He said he's not sure. So I opened a pull request. I opened, this is, I think, .map. I don't remember. But I basically said, hey, I'm talking to Ronag in OTLV, and we think it might be a good idea. And basically, I got a lot of good feedback. A lot of people, basically, when we did the PR, they opened follow-up pull requests where they added operators, and they improved the code, and they fixed bugs. So that was really cool. Special thanks to Matteo, who has been the guardian, the maintainer of streams for the longest time. And Atoan did a ton of code review. And awesome part is we got a lot of good feedback from the .NET people, from the Python people, from a bunch of people across ecosystems where I needed help with the streams API and like adding these things, and they just gave us really good, valuable feedback. So the API we have today, ladies and gentlemen, is this. Readable.from 1 to 3.map x goes to x times 2. And this actually looks fun. Unless you have a very profound like performance concern, this is the API you want. You want to treat it like an array, use map, and we have all the operators you would expect. And this is coming to JavaScript. It's part of a proposal called Iterator Helpers. We are collaborating with them on Iterator Helpers, and everything async iterable, like WG streams, node streams, everything is going to work fine with this. Yeah, I also added a slide for that. Right, so Iterator Helpers to the rescue. It's a proposal. It's stage 3, which means it's not doomed, like all the stage 1 stuff I'm working on. And it's probably going to make it into the language. Yeah, they're going to get it. So let's show some examples. So let's say I have a bunch of domains, and I want to resolve them with a DNS resolver. All I have to do is just like do .map, and I get the data. But on top of them, you can also pass concurrency here and read them like 4 at a time. And we support abort signals, so you can stop the stream, and you can stop actions. It's called deep cancellation, and that basically works. That's the important part. So everything you expect, like filter, flat map, skip, take, all that stuff is in. Now I think I'm out of time. Pretty much, right? So that's it. I will take some time to mention contributing to Node.js. We will get back to streams. I'll steal a second, right? We have 2 more people in Israel that are Node.js core team members that I helped onboard. Obviously, the hard part they did themselves. I just want to say it to mention it's possible. If you want to contribute, you basically go to Node, you clone the project, and I will find something to work on. If it's streams, that's streams. If it's funny, there is a stream behind the screen also. If it's like promise stuff, it's promise stuff. If it's web APIs, it's web APIs. If you know JavaScript, you don't have to know C++ very well. Please come and contribute. All right. Let's go back to the question slide. All right. Questions? Yeah. So that's a good question, actually. It's a pretty profound one. We had watermarks in the new API. There was a version. Let's go here. There was a version here that took concurrency, and watermark, and you could tell each intermediate stream how much to buffer rather than use the default watermark or no watermark. And it's one of those things like low watermark where we removed it just to have a simpler implementation. And as soon as someone asks for it, we will add it back. Any more questions?
Does this API accept only arrays?
No. So this is just readable.from. So like a more realistic example, I guess, is every HTTP request in Node is a stream. You can create 5 streams, sockets are streams, request response pairs, responses are streams, all of that is streams. Everything you can read is basically a stream. But the most common thing by far, I suspect, is HTTP requests. So you can take HTTP requests, you can pipe it through something that parses the body, and yada yada. I'm showing arrays here because arrays are the simplest thing you can turn into a string.
I mean, what if we, for example, want to iterate through object fields?
So if you want to iterate through object field, so you would, I guess, readable.from object.keys. There is no streaming API for object keys as far as I'm aware. Some APIs have iterable counterparts, but because of the history, object keys being ES 5.1 and iteration protocol being ES 2015, a lot of the APIs we have in JavaScript predate that APIs. That's why map on array is eager. It will map the array synchronously in one go. Whereas if you have an iterable, map is lazy. It will only map. So maybe it's a good point to clarify. Until I read from this stream, it will map nothing. It will do no work. as soon as I read like something from it, then it will start like actually doing the async stuff. Right. Pull query. Okay, I have a question in the thing I tried. Asking whether a pull stream uses a queue. So the short answer is yes. A push stream. One of the advantages of push streams. It's actually also very profound. All this stream stuff is pretty profound. The pull streams, fundamentally, they have to buffer. One of the big advantages of push streams of stuff like RxJS is that you never have to buffer with whoever is authoring the stream. There is no buffering. There is certainly no unbounded buffering. There is something we call the firehose problem. If I synchronously produce a lot of values, in the push stream case, it's not our problem as the producer. I can produce as many values as like any way I want. But in the pull stream, I can do buffering and buffer more and more and more. So let's say I have an API that like does an HTTP request, and that HTTP request, I can't control its speed. It will like come in. If I have a pull stream and I wait for you to like pull stuff, I'm stuck buffering as much data as possible. Like, and in a push stream, I buffer nothing. That's like that's one of the nice parts. Yeah. Any more questions? Yeah, this is composable. You can map, filter, flat map, all of those.
So that I can create like two readables from single stream and map them to different data types.
Mm-hmm.
Right? So basically, in this, how the flow control works in this scenario, if I have a number of implementations, a number of paths for the same pipe, and then I want to use signals or concurrency, how would it work?
Trickily? Like it's a hard question. So if you compose two streams, what should like the pull rate be? Yeah. Trickily, like I want to say like it adjusts. So we don't have an API that's like merge. We do have an open pull request for an API that does this, and there's a lot of discussions and complaints. Actually, by another Israeli guy called Raz. There's a lot of discussions, complaints, and concerns regarding like how to do it, because like the obvious solution I want to give you is like you have to accommodate the slower stream, but then the faster stream might have to buffer. If I go with the faster stream, the slower stream is stuck. So the question is, one of the things we are thinking about is maybe pass a strategy. Like so it's tricky. Okay, so I think I wish I had a better answer. So I think last question. Anyone else? Going once, going twice? All right, awesome. Thank you.